Alright, so in this video, I'm gonna be talking about another approach for few-shot learning, and we use it for the task of action recognition. The tool that we use is bidirectional attention, and the idea, the added value is just we use contrastive approach to meta-learning. So I'm gonna be focusing on this paper in 2021. Fine-grained action recognition is attracting increasing attention due to the emerging demand of specific action understanding in real-world applications, whereas the data of rare fine-grained categories is very limited. Therefore, we propose the few-shot fine-grained action recognition problem aiming to recognize novel fine-grained actions with only few samples given for each class. Although progress has been made in coarse-grained actions, existing few-shot recognition methods encounter two issues handling fine-grained actions: the inability to capture subtle action details and the inadequacy in learning from data with low interclass variance. To tackle the first issue, a human vision-inspired bidirectional attention module is proposed. Combining top-down task-driven signals with bottom-up salient stimuli, BAM captures this bidirectional attention module captures subtle action details by accurately highlighting informative spatio-temporal regions. To address the second issue, we introduce contrastive meta-learning compared with the widely adopted protonet-based method. Contrastive meta-learning generates more discriminative video representations for low interclass variance data, since it makes full use of potential contrastive pairs in each training episode. This is an example of three-way, it means three class, two-shot, it means two examples for each class, and one query action recognition. So we move from coarse-grained actions to fine-grained actions. Different polygons illustrate different categories in the representation space, with solid ones, as you see, showing the average prototypes. Coarse-grained actions can be roughly recognized by the backgrounds. So this is an illustration of proposed framework in a three-way one-shot one-query fine-grained. So we first extract multi-scale spatio-temporal features from each video clip with this backbone here, backbone network. Then extracted features are refined by the fusion of top-down and bottom-up attention in the bidirectional attention module. Predicted saliency volumes are downsampled as ground truths in the saliency supervision loss. We utilize a temporal pyramid network to fuse the attended multi-scale features to a unified representation, on which the contrastive meta-learning is performed. During training, both support and query samples are taken as anchors in the contrastive loss. In the test phase, few-shot prediction is made by comparing each query sample with every support sample in distance similarity. So we separate the fine-grained action recognition into a training dataset and test set. And there is no intersection between training and test set. So we perform M-way K-shot Q query task. And this is an illustration of proposed bidirectional attention module. schema of information flows. Here we see that its information flows in BAM, top down and bottom up. So this is the top down attention block, this is bottom up attention block, and then we fuse them and then we attended features. But B here shows the detailed structure, what is inside that. So given input spatio-temporal feature map and downsample saliency volume, BAM outputs attended feature map and saliency supervision loss. So we generate F sub A like this, and F sub T and F sub B are the functions of top-down and bottom-up attention blocks. We apply a residual attention designed to stabilize training gradients. To efficiently generate the top-down attention, we adopt a similar attention block. So average and max pooling operation are applied on F channel wisely. The outputs are concatenated to form an efficient feature descriptor, which is convolved by just a 3D convolution layer with a kernel size of 3 by 3 by 3. But for bottom-up attention block, in order to predict S from F, we devise a lightweight decoder containing again two 3 by 3 by 3 convolution layer, with the first one followed by a batch normalization layer, and you have just ReLU linearity. And we then detach a task-related gradients and impose the saliency supervision loss. So this is comparison of this one is just a ProtoNet meta-learning, but the right one, B, is proposed contrastive meta-learning. And it's a 3-way two-shot two-query task. So ProtoNet is used to fuse multiple support representation for each class. Given the support set and query set, ProtoNet aims to do this classification with this classification loss. And R sub I is just the representation of video, X sub I. Instead of image, we have video. That's it. And here, following definition of ProtoNet, P sub J, you just take average to get the proto, so this is a standard as well. So the loss of CMO is this, and A is just contains all samples from support and query sets. In the test phase, CMO straightly compares query representations with every support representation in each class to make the few-shot prediction. For N-way K-shot Q query method training episode, we denote the number of positives and negatives. The number of total contrast pairs is just the number of positive plus the number of negative. In comparison, the number of contrastive pairs can be calculated like this. But the overall objective is just the sum of this saliency, supervision loss of the I's spatiotemporal scale. And you know, these alpha and beta are corresponding loss weights, which are empirically set to 1 and 0.1. So this is a visualization of attention maps. We can compare ProtoNet with this CMO. This is a 3D projections of video representations generated by CML, but both of them have 5-way 5-shot 1 query stack, so it's a fair comparison. And you can see the mean accuracy for training for way and the query. So this is the average accuracy. We expect the loss of 1 shot to be bigger than 5 shots, but the accuracy we expect to be lower. The accuracy of 1 shot should be less than 3 shots. But not necessarily here, because in 3 shots we have less accuracy for some reasons. We proposed a few-shot fine-grained action recognition problem, which is spawned from the real-world demands. To effectively capture subtle details of fine-grained actions, we devised a human vision-inspired bidirectional attention module, where task-driven and saliency-supervised signals are combined to highlight informative spatio-temporal regions. To generate discriminative representations for low interclass variance data, we propose contrastive meta-learning, making full use of contrastive pairs in each training episode. Specific benchmark protocols are established to fairly compare different models.